Hi, it's Miss House. In this video, we're going to solve some rational equations. Now, as a reminder, we need to find that LCD because we're going to multiply everything by the LCD to clear out the fractions. Now, I only have one denominator, okay? Now, let's first make sure we recognize that x cannot be 0 because that's the one value that will make this denominator equal to 0. So we can't have an answer of 0. Okay? Our LCD is going to be just x. We only have one denominator, so that's our LCD. So 5 minus 20 over x equals 9. And I'm going to multiply every term by x. So now I'm going to reduce. Well, the first one is just going to be 5 times x. Because remember, when you multiply by the LCD, you align the LCD with the numerator. The x's will divide to 1 in the second term, so that's just minus 20. And that's equal to 9x. Now look, we have a new equation. That new equation has no fractions. It makes it a lot easier. I need to collect my variables on one side and my numbers on the other. Well, I've got a 9x on the right, so I'm going to move this 5x by subtracting it from both sides. Now 5x minus 5x is 0. So I've got a negative 20 equals 4x. To isolate x, it's being multiplied, so I need to divide. So negative 20 divided by 4 is negative 5, and that's my answer for x. Now remember, we said x can't be 0. But we didn't get 0. We got negative 5. So our answer is x is equal to negative 5. Now with all equations, you have the ability to check to see if you have the right answer. So while check is not required, I do recommend it that you at least practice it occasionally so that on a test you can actually check your work to see if you have the right answer. So I'm going to do 5 minus 20 divided by negative 5 equals 9. So that's 5 plus 4. Now where do I get plus 4? Well, look. Minus a negative 4 because 20 divided by negative 5 is negative 4, but I've got that double negative, a minus and a minus. That makes that plus. 5 plus 4 equals 9. That's my correct answer. So it's always nice to check. You don't have to do it every time. You get 2 answers, you can check just one, but you should practice checking so that when you take a test, you can check your own work on these kinds of problems. Example 6. Solve the equation 9 plus 6 over x equals x plus 10. So here's another equation where we know that our denominator cannot be 0 because here we have an x in the denominator and you're not allowed to have a 0 in the denominator. So I'm going to find my LCD. We'll only have one denominator. That means my least common denominator is going to be x. So I have 9 plus 6 over x equals x plus 10. I'm going to multiply all terms by x. So 9 times x, 6 over x times x times x, 10 times x. That's going to give me 9x plus x into x goes 1, so that just leaves a 6 equals x squared plus 10x. Now at this point, you should recognize that you have a square. And when you have a square, that means you're going to get 2 answers. Okay? So you're going to have to set it equal to 0, and you're going to have to factor to solve. So anytime you get that x squared, you have to remember these steps. So I'm going to move everything to the right-hand side so that my x squared term stays positive. So I'm going to subtract a 9x, and I'm going to subtract a 6 from both sides. Subtract a 9x and subtract a 6, and I'm going to do that to both sides. Now, on the left-hand side, 9x minus 9x is 0, 6 minus 6 is 0. So I have the 0, okay? And I get x squared plus x minus 6. So I have no fractions, but I have a quadratic equation. So I'm going to have to factor that. So I'm looking for the factors of -6 that will give me a positive 1. All right, because there's a positive 1 implied in front of that middle term of positive x. So to multiply to get -6, I got to have a negative and a positive. So I start with -1 times 6, then -2 times 3, and that's the combination that I need because that's going to give me that plus 1. So 0 equals, and I'm going to factor, x minus 2, x plus 3. Because the coefficient of x squared here is an implied 1, we don't have to worry about any splits or grouping. We just can take the factors directly from our table where we found them and put them in as the factors that we need. Now I'm going to set each one of my factors, x minus 2 equal to 0, or x plus 3 is equal to 0. So we're going to have two answers here, which is what we expected to get. So in the first one, I need to add 2 to both sides because the opposite of subtracting 2 is adding 2. And on the second one, I need to subtract 3 from both sides because the opposite of adding 3 is to subtract 3. So I get two answers. I compare them to what x cannot be, and since neither of them is 0, that's going to give me two answers, 2 and -3. Now, you're not going to know how many answers you're going to get until you've cleared out your fractions. So the minute you see that x squared term, that's when you know that you're going to get two answers. Okay? Until then, you don't know. Example 7. Solve the equation 7 over y plus 1 over 8 equals 2 over 8y. So we've got these denominators. Y is 0, 8 is 0, 8y is 0. So there's one value that needs to be excluded. 8 equals 0 is nonsense. There's nothing there that I can include or exclude. Here I need to divide by 8, and I get also y is 0. So y can't be 0. So let's make a note of that. And if we get 0, we can't include that in our answer. So here we go. 7 over y plus 1 over 8 equals 2 over 8y. My LCD, well, to find the LCD, we would factor, but none of these denominators are polynomials. They're all monomials, so there's no factoring to be done. So I'll list my first denominator. The factor missing from the second denominator is 8. And then that's equal to 8y, and that's going to be my LCD because that's what the third denominator is. So I'm going to multiply all terms by 8y. Make sure you align it with the numerator. And now I'm going to reduce where I can. In the first term, y goes into y, leaves a 1. 7 times 8 is 56. The second term, 8 goes into 8. So that's going to be a 1y. And you can put the 1 in front. That's perfectly fine. In the last term, 8y goes into 8y, leaves a 1. 2 times 1 is 2. To get y by itself, I just need to subtract 56 from both sides. This time there's only one answer because that's 1y is to the first power. So that's -54. Y is -54. Now remember, we said y can't be 0, but we didn't get 0. We got -54. So that is our answer. Y is equal to -54. Example 8. Solve the equation 8y over 3y plus 9 plus y plus 7 over 2y plus 6 equals y minus 3 over y plus 3. I'm going to set these all equal to 0 to determine what y cannot be, because none of these denominators are allowed to be 0. So these are just little 1 or 2 step equations. 3y is negative 9 divided by 3. Y is negative 3. So that's the first thing that y cannot be. It cannot be negative 3. 2y plus 6, I'll subtract 6 from both sides. 2y is negative 6 divided by 2. Y, again, we get negative 3. Y can't be negative 3. Y plus 3 is 0. Subtract the 3 from both sides. Y is negative 3. Again, y cannot be negative 3. So if we get negative 3, we can't make that our answer because it makes a 0 denominator. So I'm going to have to find the LCD, and the first step is always factor all denominators. So I'm going to go ahead and write these in factored form. 8y over, well, 3y plus 9 has a common factor of 3. To get the 3y, I need a y. To get the positive 9, I need a positive or plus 3. Plus y plus 7 over 2y plus 6. There's a common factor of 2. To get the 2y, I need a y. To get the 6, I need a plus 3. Equals y minus 3 over y plus 3. Now, the second step for LCD is to take the first denominator and just multiply that times whatever's missing other denominators. So the missing factors. You can't do this until you're in factored form. Sorry about that. Okay, so my first denominator is 3 times y plus 3. Now my second denominator, there's a 2 missing, so I'll just put a times 2 there. And the third denominator is already included because it's y plus 3 and there's already a y plus 3. So a 3 and a y plus 3, those are both in my LCD. A 2 and a y plus 3 are both there, and a y plus 3 is there. So my LCD is really 2 times 3, or 6 times y plus 3. Now, you can write it when you're doing the multiplication as the 3y plus 3 times 2, and that's what I'm going to do. And remember, it's times the top. So 3y plus 3 and 2. So 3y plus 3 times 2. Now, here I need to put parentheses because that's a binomial. 3y plus 3 and 2. And the same thing for this last one. 3y plus 3 and 2. And you could put the 6 there. You just have to do reducing fractions or division. Now, any factor that is identical can be reduced. So let's see, in the first one, the 3 with the 3, the y plus 3 with the y plus 3. In the second one, the 2 with the 2, the y plus 3 with the y plus 3. And the right side of the equation, the y plus 3 with the y plus 3. So what I have left is I have an 8y and a 2, that's 16y. Now, notice those denominators, they're all divided out. So I'm not going to write anything. I could put it over 1, but there's no point in doing that. You don't have to. Plus, here I have a y plus 7 and a 3. I'm going to put the 3 in the front because that's what we're accustomed to doing. And on the right-hand side, I have a 3 times a 2 and a y minus 3. That's a 6 and a y minus 3. So I went ahead, I multiplied the 3 and the 2 to get the 6, and then there's a y minus 3. So I have an equation, and I need to solve it. So I need to do the distributive property where I have parentheses. That's why it's so important you put parentheses around your binomials. I get 16y plus 3y plus 21 equals 6y minus 18. So 16y and 3y is 19y plus 21 equals 6y minus 18. Now notice that my variables are to the first degree, the first power. So I'm just going to solve by opposite operation. I'm going to subtract the 6y from both sides first. And I'm going to get 13y plus 21 is negative 18. Now I've got a plus 21, so I'm going to subtract the 21 from both sides. And that gives me 13y is negative 39. Now I divide by 13, and I get y is negative 3. Now I go up to compare. Y cannot be negative 3. Y cannot be negative 3, so there is no solution. Because the only answer we got is one that makes a zero denominator. So we have to exclude that from our answer. Example 9. Solve the equation 2r minus 2 over r squared plus 6r minus 7 plus 3 over r plus 7 equals 3 over r minus 1. Now I'm going to start by, like we've done on the other ones, by finding what r, in this case, cannot be. So the first denominator equal to 0, the second denominator equal to 0, the third denominator equal to 0. Now these second two are easier, so I'll go ahead and subtract the 7 from both sides. R is negative 7. Then I'll add a 1 to both sides. R is 1. Now I need the factors of negative 7. That will give me a positive 6. I need a negative and a positive. Negative 1 times 7, well, that's what I need. This is r minus 1 times r plus 7. So r minus 1 is 0. R plus 7 is 0. Add 1. R is 1. Subtract 7. R is negative 7. So it's the same as the answers we got when we did the other two denominators. So here's what we have to remember. R cannot be 1. R cannot be negative 7. That can be anything else, but if we get those two, we have to exclude them from the answer. So I have 2r minus 2, and since I've already factored that denominator, let's put it in factored form. R minus 1, r plus 7, plus 3 over r plus 7 equals 3 over r minus 1. And I know that it's just much easier if you put binomials in parentheses. You make less mistakes. So I just went ahead and did that. Now, I have to multiply all of these by the LCD. So I'm going to create a little bit more space here, if I can. Okay, so my LCD is going to be the first denominator, r minus 1, r plus 7. And notice that both factors in the other two denominators are already included. So I'm going to multiply by r minus 1 and r plus 7. And align it with the numerator, r minus 1 and r plus 7. R minus 1 and r plus 7. Now, I'm going to reduce r minus 1 and r minus 1, r plus 7, r plus 7. R plus 7 with r plus 7, and then the last one, r minus 1 with r minus 1. So I'm going to write what's left. Here there's a 2r minus 2. There's nothing else left, so I don't need parentheses anymore. Plus 3r minus 1 equals 3r plus 7. So I need to clear my parentheses first. 2r minus 2 plus 3r minus 3. Don't forget, you're distributing to both. Equals 3r plus 21. Now, on the left-hand side, I have like terms, 2r and 3r. Before you start to move things, you need to simplify each side. So then I have a minus 2 and a minus 3. That's a minus 5 equals 3r plus 21. Now I need to get my r terms on the same side, so I'll subtract a 3r from both sides. That's going to give me 2r minus 5 equals 21. And now I'm going to add 5 to get the numbers on the same side. So I get 2r equals 26. Divide both sides by 2. R equals 13. Now I'm going to look at my excluded values. 1 and negative 7. Since that is not the answer that I got, r is 13, that means r equals 13 is indeed my answer because it's not one of the excluded values. So r equals 13. So you can always check at the end, but I find you're less likely to make a mistake and include an excluded value if you think about those up front. Okay, so think about those values that the variable cannot be before you solve, and that way you'll be alerted to that and you won't accidentally put it in the solution. Example 10. X plus 1 over x plus 9 is x squared minus 83x over x squared plus 7x minus 18. Subtract x minus 9 over x minus 2. So I'm going to look for my excluded values first. X plus 9 equals 0. Subtract 9. X is negative 9. And it would make a 0 denominator, so x cannot be negative 9. X squared plus 7x minus 18 equals 0. Well, that one's going to require factoring because it's got an x squared. I need the factors of negative 18. That will give me a positive 7. Negative 1 times 18, that's not it. Negative 2 times 9, there it is. So it's x minus 2, x plus 9 equals 0. X minus 2 equals 0. You add 2, you get x is 2, which means x really cannot be 2. X plus 9 equals 0. I need to subtract 9. X cannot be negative 9. And if you want to do this last denominator, you're going to get x equals 2. That's the same one that we already got. So you can do that. X minus 2 is 0. Add 2. X is 2. And we've already said x cannot be 2, can't be 9. Negative 9. So I'm going to multiply by my LCD. Well, I got to find my LCD. My LCD is the first denominator, x plus 9. Now, we factored the second denominator already. Here it is. There's an x minus 2 missing, so I need an x minus 2. And that is going to already include that third denominator. So x plus 1 over x plus 9 equals x squared minus 83x over x squared plus 7x Let me go ahead and write that in the factored form. So that's x plus 9 and x minus 2, and then minus x minus 9 over x minus 2. And I've got to multiply everything by this LCD. So put parentheses around all binomials. Multiply by x plus 9, x minus 2. So x plus 9, x minus 2. Be sure you align it with the numerator. X plus 9, x minus 2, and then x plus 9, x minus 2. I'm going to reduce out the common factors, x plus 9, x plus 9. That's going to leave me with x plus 1 and x minus 2. And it's important I have those parentheses so I'll remember to FOIL that or distribute that out. X plus 9 with x plus 9, x minus 2 with x minus 2. That's just going to leave x squared minus 83x, so I don't need any parentheses. And then here, this is going to be a really tricky part. This is going to give me a minus parentheses x minus 9, x plus 9. So if I multiply out and simplify all this stuff, remember, first, outer, inner, last, I will get x squared minus 2x plus 1x minus 2 equals x squared minus 83x minus, now be careful, multiplication comes before subtraction. So I have to multiply this, and if you notice, these are conjugates. They're exactly alike, except one has a minus and one has a plus. And that means that when you do the outer and the inner, plus AB minus AB, those are going to cancel out. Okay, so that's going to add to 0. Pencil's acting up. 1 minute. So you end up with a squared minus b squared. So here I'm going to end up with x squared, and it's still in parentheses, minus 81. And that's going to be the trickiest part of this whole problem, because you've got to remember that you're going to apply this minus to both of these things. Both of those terms are going to get a minus. So on the left-hand side, I'll simplify. X squared minus 1x, and you don't have to write the 1, but it's okay if you do, is x squared minus 83x minus x squared plus 81. And that's the toughest part of this problem right there, getting that sign right. So on the left-hand side, I still have x squared minus x minus 2. On the right-hand side, I can combine like terms. X squared minus x squared is 0. Negative 83x plus 81. So that's not going to simplify. So that's just going to be minus 83x plus 81. So I've got to get everything on one side because, remember, you got an x squared. That means I need to set it equal to 0 and factor it to solve it. So let's see. I need to add an 83x, and if you do it to one side, you have to do it to the other side, and I'm lining them up. I need to subtract an 81, and I get x squared plus 82x minus 83 equals 0. Because there's a 1 in front of that x squared, all I need to do is find the factors of negative 83 that will give me an 82. And look, the first one, negative 1 times 83, is what I need. So I have x minus 1 x plus 83 equals 0. X minus 1 equals 0 if x is 1. Add 1 to both sides, right? X plus 83 is equal to 0. And if we subtract 83 from both sides, we get minus 83. We go back to the top and we compare to our excluded values, which were -9 and -2. And we didn't get -9 or -2. We got 1 and -83. So that is my solution.